Yeah, hi everyone. I'm Amol Research. So I'm the part of the GCD program at INSEAD, and as a part of the EDA, I'm doing the project on the exploratory data analysis. So yeah, for this EDA project, I've chosen the Premier League as a data set, which I'll be doing the complete EDA on the Premier League data set. Before moving ahead, I will be just giving you the brief history about this EPL. So EPL is a very famous, popular league in the UK, which is played by the 20 clubs in a year, which starts in the month of August and which ends in the next year of the month of May. So there are overall 20 teams, so 38 matches against this 19 opponent, out of which 19 are played at the home ground, while the 19 matches are played at the home ground of the opponent. So total 38 matches are played by each club, each team. And we have the data for the 25 season, starting from 1993 till 2017-2018. And as a part of ED, we'll be doing the analysis and we'll be finding out the evolution of this EPL across this overall the season. In this session, I will be sharing the session on the PPT as well as the Python code. We'll be initially looking after the Python code, and later on the extract of the Python code, the data visualization, data analysis, what I've done has been pulled out in this presentation, and we'll be moving to the presentation to see what are the analysis what we have done with this for this data set. So prior to that, EDA process, like EDA is an 8-step process. We start with the data acquisition. In the data acquisition, we have received the data set from INSEAD for the English Premier League, which are having the multiple features available in that, and multiple data is available for the complete 25 season. So the first part is the data acquisition. Once the data is read, the second stage is of the data review, where we understand what is the data, what are the data types, what are the various values, what are the min values, what are the maximum values, whether there is any correlationship between the features. For that, we use the pre-profiling, like we are using the Pandas pre-profiling report here. We understand the data characteristics, and once that is done, we are moved to the next phase called the data cleansing. In the data cleansing, we do the multiple operation to clean the data. For example, it can be a dropping of the unnecessary column. In the data set, we can find out there are multiple columns, some of the which may not make sense in the visualization, which are the unnecessary stuff. So we can drop those columns. We also need to do the substitute the missing values. So in the data set, there are some values which are not available. So we need to do the substitute the missing values. There are multiple ways of substituting the missing values based on the operation, based on the data set. We can either do it with the min, mode, max, minimum, 0, 1. So we need to understand the data set, which is a part of pre-profiling. And based on that, we will be taking the decision what are the substitute values. We will be doing that. The next part can be also the addition of the features. For the better analysis, we might need to add some of the additional features in the data set so that we can also have a good analysis with respect to those features. So these are the steps, part of the data cleansing, data pre-processing operation. And once again the data pre-processing is done, we again do the post-profiling to just check all the data is now in the right form before we start the visualization activities. So after post-profiling, we use the various type of analysis: univariate, bivariate, multivariate analysis. And for the visualization, we use the library from the Matplot or a Seaborn, where we do the visualization of these features, try to understand what those features says, what are the relationship, what is the meaning of that data, with the help of the visualization charts like bar chart, line chart, plot chart, area plot, histogram, scatter plot, density plot. So there are multiple plots available. Based on what type of data we are trying to analyze, we can use the variety of the plot. And once we have done the analysis, we do the conclusion. What are the findings from this data set? So this is about the 8-stage process of the EDA. For this, will be using the Google Colab which is a Google Colab platform, which is used for the executing the Python code, and also it has a rich visualization. So in this project, we'll be using the multiple libraries from Numpy, Pandas. For profiling, we are using the Pandas profiling, and for visualization, we'll be using the Matplot and Seaborn. So I will move to my slide next to the Python code, where we will take a quick overview of the Python code. And again, we'll come back to this presentation where we will be seeing the analysis what we have done with the help of the Python code. Yeah, so this is my Python code, what is done for the EPL EDA analysis. So as a good engineering practices, we start with the introduction about this data set. So we have already done the introduction about this EPL data set. What is this? About the history of the EPL. We mentioned the problem statement. In this, the problem statement, I would say, we are more interested in doing the analysis and trying to find the evolution of EPL across this 25 years, since we have the data starting from the beginning of the season 93 till the 2017-18. So we'll be trying to evaluate how this EPL has evolved in this 25 years. The first stage, the first step in the analysis or any Python project is installing and importing the libraries, followed by any upgrades are available for those library, upgrading those libraries to the latest one. And here we start with the coding. Like first we import all the libraries what are required. As we mentioned that we will be using Numpy, Pandas, so we are importing those library. For profiling, we are using Pandas profiling. Also, I have taken the option of Sweetwiz also, which is the alternative option for profiling report. We are initializing the visualization with the max column, minimum column. So all these are the initialization what we have done. We are importing the Matplotlib library and the Seaborn library for the visualization purpose. So this is our data set, which has having the 11 features, name as division, date, home team, away team, full-time, home team, home goal, full-time, away goal, full-time result. Similarly for the half-time, and the final one is the season, which season this match was played. So these are the 11 features available in the data set. So we'll be reading this data set, which is available on the GitHub. And this is the data head what we are seeing for the first file, where we can see the data available. So seasons are the season in which match is played, while the division is the division of the team, and the date when the match was being played. So this is the top overview of this data, raw data, what is available with us. We'll also try to see the data, we'll describe the data. In the describe data, it's more on the numerical data, what is available. So we can find out that there are almost 9,664 data available in this data set. Some of the data, like halftime result, it's only 8,740, which means some of the data is missing in the halftime goal. We can find out that in the full-time goal, that maximum goal done by the home team is the 9 goal, while in the full-time away goal, it's a 8 goal maximum goal done by the away team. So this is the overall, like what is the minimum goal, maximum goal, what are the average goals. We can find out that the average goal is almost 1.5, which is almost more than 1, I would say. And for the away, it's almost 1 goal is the average goal done in each match. So these are the observation also what we have plotted in this Google Colab in the observation section. We are also finding out the data type, like what are the data type of this all 11 features available. We can find out that except the goals, all are the object type, and in goal also the full-time goal are mentioned as an integer data type, while the half-time goal are mentioned as a floating type in the raw data set. So the goal need to be corrected also here in the data preprocessing. Here we are seeing the data count. So this is the data count which gives for the each column, and we can find out that all the columns except this halftime columns has the less data. So there are missing values in the halftime goal and halftime result, which need to be corrected in the data cleansing operation. The another instruction to find out the same thing is with the finding out what are the null values, and again the same thing, like we can find out that there are null values in the half-time results. So these are the alternative to the data count to find out the data null. So we have basically reviewed the data as a step number 2, and the third step that we will be doing is the data pre-profiling. So we are using the Pandas pre-profiling, and in the Pandas pre-profiling we can see the Pandas profile here. So this is a Pandas profiling, pre-profiling, and we can see that the Pandas has made us ready-made available the profile report, which is that the number of variables are 11, out of which 7 are categorical and 4 are the numerical values. The missing values is 2,772, which is almost 2.6% of the data is missing in this data set. And similarly, like each column wise also we have the analysis with this profiling report. For example, division. So in the division, we can see it is a distinct, like it has only one values, like the value seems to be E0 in across all 9,664. So it is a one common values available in the all the data set. Similarly, the date, we can find out that there are 2,572 distinct values, while the rest of the dates seem to be overlap or common. So this is a pre-profiling, and once we have done this pre-profiling, we'll be starting with the data pre-processing or data cleaning operation. In the data cleaning operation, the first stage is that we'll be dropping the unnecessary column. We have find out that the division, which is not making any sense because it is a common across all this the complete data set, so it is not making any sense. So we'll be dropping the division column. We're also dropping the date column because we are more interested to see the analysis based on season. We have the additional column which is available season, so we'll be doing on that, and so we don't need date column. So the date column is also been dropped. We'll be doing the handling the missing values. So we have found out that there are some null values available in the half-time result. So for the null values, we are choosing the approach to replace it by the 0, since we are more interested and we don't have the data available for the earlier data. So we had a multiple approach. Either we can go with the mean mode or a median type. But again, since this is a half-time data, we are more interested in the full-time results. So we'll be replacing it with the 0. We are understanding that there were no goals made in the half-time part. So 0 values we'll be considering for the missing values. So once this is done, we'll also do the data type correction. We have found out that the half-time results were in the floating point. So this need to be corrected to the integer data type. So we have casted this data type to integer format. So the third correction has been made in this data set. And the last the thing what we have done is that we have added new feature. We have added the new feature name as a winner and a loser. Since we are having the data in a general format like the full-time results, it mention only the which team has won, away team or home team. So for a better simple analysis, we'll add one more column, a winner column. Based on the FTR, we will plot this, whether it is a home team, away team, and we'll use that name in the winner column. So this will help us to do the winning analysis. So we are adding this additional column in our data set. Similarly, we will be also adding the loser column. Since we have the winner, there will be a second team, which will be a loser. In case of draw, we will be using the result as a draw in both the columns. And here is our final data set. So we are once again seeing the data info, and we can find out that all the data type are corrected. All the values are there, 9,664 across all the ranges. So this completes our data cleaning operation. And now we are ready with the next stage, that is a data post profiling. In the post profiling, we'll run the post profiling, and we can find out that again there are 11 categorical variables because we have added 2 and we have deleted 2. So the count remains same, 11 variables, out of which 7 are categorical and 4 are numerical. We can find out that there are no missing values now available in our data set. and the total observations remain same, that is 9,664 rows. So this is about the profiling, and once the data post profiling is done, now we are ready with the EDA part to do the start with the exploratory data analysis. In the exploratory data analysis, I will move back to the PPT again, because all this plot what I have done in the Google Colab, I have extracted those in the presentation. So we'll run through the presentation for a quick analysis. Yeah, back to our presentation. We have seen the EPL history. So this is a overview, I would say. Like based on the data analysis, we have found out that Manchester City was the team who have been consistent. I would say they have won 3 times since 2011-12. We have taken the data from 2011-12 onwards till 17-18. So they have been the winner for the 3 seasons, followed by the Chelsea, who have been a winner for the 2 seasons, and then Manchester United and Leicester respectively for 1 season each. Yeah, so this is the first plot of what we have done. Like we have the data from 93 onwards. So we have found out that how much matches are played in each season. So the first season there were 462 matches, while the rest of the seasons there are 380 matches. So it means the first 2 seasons, after the first 2 seasons, the matches were being changes to made to 380 matches. We'll see what are the reasons for those also. We have seen the second thing is that team-wise the matches played. So the Arsenal is the team. Arsenal, Chelsea, Liverpool, Tottenham, Manchester United are the teams who have played maximum number of matches, almost more than 900, followed by the Aston Villa, West Ham. Those are the teams. So this gives us the understanding that these teams are being quite consistent and they have been playing the matches from the beginning of the season. So like we have seen that initially first 2 seasons there were more number of matches, and we can see that the number of teams were initially 22, and later on from the next after this 2 seasons the number of teams are 20 teams. So that's the reason the number of matches for the first 2 seasons were more as compared to the rest of the season. Later on the team size was restricted to the 20 number of teams, and the matches were 380 respectively for each season. This is the analysis for all the season, like home team versus away team winning analysis, and we can find out that the red plot, which is for the home team, while the blue plot is for the away team, while the green plot is for the draw, whether the match is draw. We can find out that the home team winning probability is much more in each season. So the team which is playing at the home has a good chances of winning the matches. So this has been the overall analysis across all the season, what we have plotted in this graph. Next, we will be doing the analysis for 1 season, 2017-18. And so we'll be seeing the different type of results, what we have tried to extracted for this season 17-18. So the first thing is the winner, and we can find out that the Manchester City was the team who have won the maximum number of matches. Like there are 38 matches, so out of 38, 32 matches were won by the Manchester City, making them the champion for this season, followed by the Manchester United, who have won 25 number of matches, and then followed by the Tottenham, Chelsea, Liverpool in the order. So this is the winning team analysis. Similarly, we are also making the losing team analysis. So who are the team at the bottom? And we can see that the Swansea, who have lost 21 matches of the 38, had made it at the bottom of the chart. Like it was the 28th number of team in the season 17-18, followed by the Huddersfield, Stoke, Westford, and West Brom in the order. We are also plotted the home team versus away team match analysis team wise. So we can see that Arsenal has the blue color is for the home team, while the red color is for the away team. The Arsenal has more win at their home as compared to the away ground. while Manchester City was the only the team who has very consistent result that they have won 16 matches at home, while 16 matches they have won at the opponent ground. So Manchester City with the 32 matches with the 50-50% ratio at both home team as well as away team. So this is the plot which gives us the analysis like how was the team performance at their home ground versus their performance at the opponent ground. Scatter plot, this gives a good idea like which teams were present across all the season. We can see that the teams on the x-axis while the seasons on the y-axis, and we can see the which teams are present in which season. So there are teams like Arsenal, Chelsea, Manchester United, Tottenham, Everton, which were present, I would say, for almost all the seasons starting from 93-94, while team like Brighton, Huddersfield, these are the teams which were present in the 2017-18 only. Similarly, the team Swindon, which was present only in the 93-94. Same is with the Oldham, same is with the Sheffield United, which was present in 93-94 and then 2006-2007. So this gives us the idea. This gives us the idea like which teams were present in which seasons, and a general overview of the evaluation of the team with respect to the seasons with respect to the year. The same chart we have plotted in the bar chart format, which gives us the idea of number of season played. Like Arsenal have played 25 number of season, followed by Chelsea, followed by Everton, Liverpool, Manchester United, and Tottenham. So these are the 6 teams, I would say, who have played almost all the seasons, while the teams like Barnsley, Blackpool are the teams which have played hardly one number of seasons. So with this we come to know the team presence across all the seasons. So coming to the conclusion, we have seen that there were total 50 number of teams who have participated in till date from the season 93 till 2017-18. Except first 2 seasons, the teams matches are 380 matches per season. Each team plays 38 number of matches, 19 at home and 19 at the opponent ground. We can see that almost 10 teams are there who have played more than 700 matches, means those who are present for many seasons, while team like Arsenal, Chelsea are the only 6 teams who have played more than 900, which means they were present almost all the seasons for this EPL. So some of the actionable insight also what we have taken apart from what I mentioned in the each plot is that the team playing at the home has most probable chances of winning matches. The second insight also what we have taken is that the team which is leading in the halftime result has good chances of winning the matches. So team which has won the halftime result has most probably win the full-time match. And we also seen finally the consistency of the team. Like there are only around 10 teams which have been, I would say, the consistent across all the season. So these are the insight what we have plotted from this data set. Yeah, so finally I would like to thank the INSET team, especially the mentors, Mr. Suchit Muzumdar and Mr. Arun, who have been the instructor for this season, helping us to understand starting from the data science, I would say data visualization and the EDA part. Also, thanks to all the information sources which is available through INSET, through Google, and through the various, I would say, the YouTube program. So yeah, thank you very much. Hope you have liked this EDA. Thanks for connecting.